Dr. S. Tamarai Selvi is working as a professor in the Department of Computer Technology, MIT campus of Anna University, Chennai. She has over 30 years of teaching experience. Grid computing, cloud computing, and e-learning are her areas of interest. She has successfully completed 12 research projects funded by Government of India and Tamil Nadu state government. She has established Center for Advanced Computing Research and Education and acquired 1 patent and has filed for 3 more patents in her research area. She has presented over 110 papers in international conferences and published 45 papers in international journals. She has authored 5 books. The latest book is titled Mastering Cloud Computing, published by Morgan Goffman Publishers 2013.
Welcome to UGC lecture series on computer science. We are discussing about the subject cloud computing. So far we have discussed about the need for cloud computing, introduction to cloud computing, and also the various recent trends for which cloud computing is a key enabler for various applications. And in this episode we are going to discuss about virtualization. Actually, we have discussed about the cloud computing based on the various aspects of its application in the previous episodes. Today, I am going to focus mainly on the concept of virtualization, then what are the various hypervisors available, followed by conclusion. We have discussed the cloud computing as sharing of services, and whenever you share the services, it may be an application, it may be a platform, or it may be an infrastructure. Whenever you consider the sharing of infrastructure, mainly it discusses about the distributed computing principles. So, cloud provides sharing of infrastructure for distributed computing. Virtualization is one of the important concepts which we have to learn for understanding the concept of cloud. We should know the basics of virtualization. See, whenever you consider virtualization, it is a technology that can benefit computerized commercial businesses as well as the government organizations. So, when you make use of the virtualization technology, it is very much profitable for so many commercial applications as well as for the government applications. Also, virtualization enables creating virtual machines on physical machines using software. We are very much using the software in computer applications. It is possible to create virtual machines from the physical machines, so that the concept of virtualization is applied for multiplying the single resource into many. And also it is a proven software technology that is rapidly transforming the way that people compute. When you consider the definition of virtualization, it is a technique for hiding the physical characteristics of computing resources to simplify the way in which other systems, applications, or end users interact with those resources. Actually, it hides the physical resources. What is the meaning of it? We are having real resource and we want to create something virtual. So, from the real resources only you can create virtual resources, and for that we are having different concepts or different principles to be followed. When you consider the history of virtualization, we can say virtualization was first presented in time sharing in large fast computers in 1959 itself as an extension of the work being done into time sharing on mainframe computers. First they used the mainframe computers for many applications. That means you can run 2 or 3 programs at a time, and the mainframe was using the time sharing concept. For one application it will be spending about a few milliseconds, then it will be working on another program to spend some other milliseconds. So, it will be switching over to different applications, and that is called as time sharing of this mainframe computers. Then the term virtualization originated in the IBM M44/44X project. Here M44 refers to the hardware and 44X is the actual virtual machines used in it. In 1970, IBM's research continued through many other projects and were soon joined by projects at other institutions such as MIT's Multics. And IBM first released the VM 370 for System 370 mainframe in 1972 after the earlier prototypes on S360. So, all of these systems ran virtual machines identical to their hardware. Then in the year 1980, personal computers phased out the mainframe computers and people were concentrating on developing purely virtual machines. By the year 2000, there was a massive need for servers to run the internet applications. So, development of server virtualization was also there by using the different software such as Zen and VMware. Then the desktop virtualization was also popular. After that, in 2010, we had the application virtualization also. So, these are the various levels evolved using the virtualization. Now, when we consider the virtualization concepts, how do we actually explain the meaning of virtualization? Whenever you consider virtualization, we are having the real machines as well as virtual machines, or in general we can say real resources and we are getting virtual resources from the real ones. So, first of all we should consider the various resources at the bottommost layer. So, the resources are the components with the various architect, interfaces and functions, and mostly they are physical or they are real resources. It may be centralized or it can be distributed also. See, the various resources which we are considering are the memory, disk drives, networks and servers. So, it can be anything. So, these are the physical resources or real resources. Then we are having a process called virtualization process, and we can call it as a substitution process also. It creates virtual resources and maps the virtual resources to real resources. They are primarily accomplished with software and or firmware. Then from the virtualization process, we are able to get the virtual resources. So, by having the substitution of the real resources, we are having different resources created and we can make use of the same interfaces or functions of the physical resource, or different attributes can also be used to access the virtual resources. Then we are having the part of the physical resource or may span multiple physical resources by using the virtualization process. So, we are having the real resources, we are applying the virtualization process. Using the virtualization process, we are able to get the virtual resources. So, this is the basic idea. Now, when you consider the virtualization, we can give the definition in this way also. Virtualization combines or divides or modifies the resources or computing resources to present a transparent view of one or more environments. So, what is the meaning of combination or division or modification? That means it is used for sharing resources, or it can be used for aggregating resources, or it can be used for emulation purpose, or it can be used for insulation or isolation. So, these are the various functionalities which are helpful to create the virtual resources. So, when we consider the previous points which we have discussed, the various virtualization functions can be considered in this way. See, first of all, we can have the sharing function. You are having the physical resource at the bottom, the actual substitution process or the virtualization process is sharing of the resources. So, one resource is actually shared by multiple resources, or we can say in this way, a single resource is created into multiple resources. So, the one real resource is shared and you are getting multiple resources. This is the meaning of this diagram. Then coming to this one, the second substitution process or virtualization process is aggregation. You can have many resources, physical resources. The many physical resources are combined together or aggregated together, so that you can create a single virtual resource which is having the capabilities of all these physical resources. So, aggregation is also another virtualization function. Then next one is emulation. So, you are having the physical resource of type X. It may be using a different architecture, it may be using a different instruction set, etc. And you can have the function called emulation to change the resource type X into resource type Y. So, here the virtual resource is considered to be type Y, the original physical resource is type X. So, by using the emulation process, we can create the resource Y from resource X. So, resource Y is the virtual resource and resource X is the real resource. Then the next function is insulation. See, here the virtualization process is called as insulation. You can add or replace or change some of the resources in the physical resource itself, and by means of these functionalities it is possible to create the virtual resources. So, here also we are totally isolating or insulating the physical resource and you will be having a virtual resource. So, we can say that sharing, aggregation, emulation and insulation, these are the various functions which are helpful to create the virtual resources from the physical resources. So, we can tell in this way MN mapping. The letter M represents real resources, N represents virtual resources. So, we can have the virtual machine to be considered as M number of real resources are converted into N number of virtual resources. And when you consider the grid computing, you are having M real resources. It is mapped to a single virtual resource, that is called as grid computing. We are aggregating the different real resources into a single resource, so that you are getting high performance computing power. In case of cloud computing, we can say one physical resource is converted into n number of virtual resources. So, a big N server can be converted into n number of virtual machines, that is called as 1 to n mapping. So, in general we can say virtualization is mapping m number of real resources to n number of virtual resources. Now, this is another diagram to represent the virtualization concept. So, you are having different physical hardware, you are having the processor, you are having the memory, you are having the IO devices, you are having the graphics facilities. It is possible to make use of this single physical hardware, which can be used for creating one virtual machine in which you can have the Windows software. It can be used for some productivity. Then you can make use of some web browser install in it in some other virtual machine, so that it can be used only for web browsing. Then you can have some other operating system installed in the another virtual machine and it can be used for gaming application. Then you can create another virtual machine in which media server can be used for your application. Then another one can be used for security and other manageability. So, if the real resource or physical resource is having the capability to create these 5 virtual machines. The single physical machine is having 5 virtual machines, and all the 5 virtual machines are having separate operating systems, separate applications for the separate purposes. So, this is the concept of virtualization. Now, in this case you can see 3 different operating systems are available. This is available in one real resource, this is available in another resource, this is available in another resource. So, you are having orange color, green color and blue color representing different operating systems in different machines. When you are having a big end server, it is not necessary to have 3 separate systems to be executed. Instead, you can bring all the 3 operating systems into 3 virtual machines where it is housed in a single physical machines. So, we have discussed the basic concept of this virtualization, and let us go for a small break. Welcome back after the break. Now, we are going to just discuss about the need for this virtualization in industries. Actually, industries are facing lot of challenges. The first thing is cost. The industries are trying to reduce the cost of the product being developed, and for that purpose, what are the possible ways to reduce the cost? Cost means it involves managerial cost, production cost and maintenance cost. So, when you consider all these types of costs, in what way virtualization is going to help the vendor or the manufacturer or the industries to reduce the cost? Virtualization is very much useful in that aspect. Then we are having the changes. See, changes are inevitable in industries. As far as any software is available, definitely it requires lot of changes, so that you will be getting next versions in the subsequent years. If there is no change in the software, means the users are not using the software, that is the meaning of it. So, always it is subjected to different changes in the actual versions of the software. So, whenever you want to save the changes, it requires the changes in the hardware also. Is it possible to change the hardware frequently based on the need of the actual changes required in the development of the software? It is not feasible, it is not economic. So, how to accommodate the changes in the software or hardware? For that also virtualization is helpful. Then next, another important challenge is complexity. Today the applications are developed for simple operations to complex operations. It involves lot of vendors to be combined together, and they are creating very complex applications. So, in that case, based on the complexity, the development requires lot of changes in the hardware, in the software, so much of collaborations in the distributed environment. So, for that complexity, virtualization is also catering the needs. Next one is compliance. Whenever you think of compliance, how it is possible to have the interoperability, whether it is compatible with the existing hardware or with the existing software, all those things are matter. We are getting new application softwares developed by different vendors. So, if you want to switch over to the next type of software, the machine may not be having the actual compliance. So, once if you want to have the compliance, virtualization is also helping to provide solution for the interoperability. So, these are the various challenges we face in the industries, and in what way virtualization can help to support all these issues. For that matter, we should understand the various advantages, or we can say why should we need virtualization. First of all, to have the increased performance as well as computing capacity. by increasing the number of machines, it is possible to increase the performance and it increases the computing capacity also. Sometimes if you are using a single machine to execute one job, even though the machine is having the capability more than that actual requirement of the software, the underutilized resources are kept idle. So, how to keep the underutilized software or underutilized hardware to be used for some other application also? For that, virtualization is helpful. Sometimes you may not be having enough space to accommodate all of your systems. So, whenever you are having the lack of space for different systems, you can keep a single big end system, and that is possible to create number of virtual machines. Then greening initiatives. When you consider the greening initiatives, it is essential to maintain green environment, because when the system is switched on, the carbon emission is taking place, because all the computing resources are having its silicon chips kept inside the box. So, whenever it is running, automatically the carbons are emitted from that silicon chips and it becomes the pollution of the environment. So, for that purpose we want to have the minimum carbon emission. For that purpose, the only thing is we have to switch off the machine, but all the time we cannot switch off the machines, because when you run the applications, the machines to be switched on. But at the same time, it is not essential to switch on all the machines for 24 hours. Say for example, during the night time, it may not be necessary to run all the computing systems. So, you can just switch on any one system to cater the needs of the requirement, whereas all other systems can be switched off, and during the daytime you can switch on all those systems. So, for that purpose also virtualization is helpful. That is why we are able to initiate the green IT using virtualization. Then it is a problem of increased administrative cost. The companies are facing the problem of increased administrative cost. To reduce the administrative cost, the virtualization is helpful. And when you consider the resource virtualization, what are the various components or different parts of the computers or different entities that can be virtualized? The first one is memory virtualization. The process feels like it has its own address space, that is called as memory virtualization. We are configuring it by using the operating system. So, everybody would have been heard about virtual memory. Even though you are having only 2 GB of your RAM capacity, it is possible to run 4 GB worth of software. By having the swapping of the part of the software back and forth to the hard disk drive, it is possible to utilize the memory. That is why we say that it is virtual memory. The real memory size is 2 GB, but it is possible to run 4 GB application or 8 GB application by having the swapping of all those things. Then we are having the storage virtualization. It is the logical view of disks connected to the machine. You can have the external pool of storages available in different locations, so that it can be in the distributed environment. It is possible to have the different types of storage, as well as you can have the different varieties of storage. It is possible to apply the virtualization, so that we can achieve the storage virtualization. Then you can have the CPU and machine virtualization. You are having a single CPU. By creating multiple processing capability, it is possible to create virtual machine. So, that is called as CPU or machine virtualization. Then input output virtualization. The input output devices can also be virtualized, so that by having a single resource, it is possible to create multiple IO devices. Then next one is network virtualization. Network is also another entity. It is possible to create virtual switches or virtual router, so that you can have the virtual resources from the physical resources. So, we are having the different parts of the computers which are considered in the distributed environment, such as the memory, storage, CPU, IO devices and network accessories. All those things can be virtualized. That is why we call them as resource virtualization. And to understand the concept of virtualization, it is essential to know how the computer is organized. What is the actual architecture being used? When you consider the computer systems, they are constructed out of the three major components as shown in this figure. One is the hardware components, the next one is the operating system, which is actually activating the hardware components based on the instructions given by the user's applications. Then third one is the actual applications you are using it in your computer. So, hardware, then you are having the operating system, then you are having the applications. Actually, these three major system components are stacked one over the other one, reflecting the direct interaction that takes place. The hardware is actually divided or separated from the other components by using instruction set architecture. So, this is the division between these two. Now, let us discuss in detail about this particular concept of the different components available in the computer system. Actually, computer systems are built on different levels of abstraction. So, the higher level of abstraction always hides the details at lower levels. Suppose if you consider the computer, you are having the hardware, you will be having the hardware in terms of main memory, then I/O devices, various controllers, system interconnects by using the buses, then memory translation, various controllers and execution hardware. These are all the various hardware components. Then you are having the various softwares, some of the drivers you will be having driver software, memory manager, scheduler, operating system, all those things are available. Then some of the libraries we are installing over the operating system. Some of the application programs are also available. So, mainly we are having two divisions, one is hardware, another one is software. So, the higher level abstraction always hides the lower level abstraction. Whenever you make use of the computer, only you are exposed to the software. You do not realize that the hardware is actually doing all the operations for your commands. So, that is why there is an abstraction. Files are an abstraction of the disk. Even though you are having the hard disk where the files are stored, when you open the particular content in your hard disk, you are opening it in the form of a file only. So, file is an abstraction of the disk or hard disk. Now, the different perspectives on which the machine is developed, we can explain it by having this particular layers of this computer, and we are having the total abstraction of the machine, and let us discuss about this in the next episode. So far we have discussed about the need for virtualization and also what are the various functionalities we are having to achieve virtualization. To understand or to revise the concepts which we have discussed so far, you can have the answers for the following questions. First of all, you should know what is virtualization, then what are the challenges faced by the various industries, then you should know what are the limitations of the different applications which we are developing in current scenario. Next one is what is the actual perspective of the computers by considering different layers, or in other words, what are the major components of a computer. So, if you are able to answer the questions, you may be able to revise the concepts which we have discussed in this episode. Thank you.